Today, we'll be dealing with counting schemes and simulations for games with more than one player. To begin, create a sampler like the one shown here. This could be a simulation of two players rolling a die. But notice, player 1 is using a fair die. But player 2 has a die that has 2 times as many sixes as player 1. Run the sampler to see how it works. Now, let's define a function that picks the winner for each roll of the dice. Use an if function. If player 1 equals player 2, then print tie. But if player 1's score is greater than player 2, then print player 1 wins. And if not, then print player 2 wins. Next, let's graph the results and run the sampler 1000 times. So, this graph shows how often player 2 wins over player 1. The scores are tied 156 times out of 1000. And, for the remaining 834 rolls, player 2 wins 457 times. So, when there is a winner, player 2 wins 54% of the time. But, there is another way to find the probability of winning these kinds of games. The way we just used is the empirical method. It works by creating a simulation. The other way is an analytic method. It starts with the fact that the probability is defined to be the total number of ways of winning divided by the total number of possible outcomes. Often, one or both of these quantities are easy to find. For example, for this simulation, 6 different outcomes can occur for player 1, and 7 different outcomes can occur for player 2. So, altogether, 6 times 7, or 42, different outcomes can occur. To see all of these outcomes, switch the sampler to use 2 counters instead of 2 mixers. And, run the sampler 42 times. Counters are different than mixers because they deal out items one at a time and in a specific order that does not repeat items. So, using counters, each possible outcome will occur only one time. Now, graph the results. And create bins that include only one type of item. Do this for both player 1 and player 2. Then select Winner from the table and the graph will show who wins for each possible outcome. Now, count the blue data points to find how many times player 2 won out of 42 trials. And, count the green data points to find how many times player 1 won out of 42 trials. In fact, this graph also can be used to answer the following kinds of questions. 1. What is the likelihood that player 2 will win if he rolls a 4? 2. What is the likelihood that player 1 will win if he rolls a 4? 3. What is the likelihood that player 1 will win if he rolls a 3 or higher? And so on. Here is a brief summary of what's been shown here. For a 2-person game in which one person was using an unfair die, we used 2 different methods to calculate each player's probability of winning. The first method used a simulation and was based on a sample size of 1000, whereas the second method used counting procedures. Notice that, for the sample shown here, the 2 methods give estimates that are close to being equal. But, they are not exactly equal. However, if empirical estimates are based on larger samples, or if the simulations are run a number of times, then the average estimates will converge to the estimates that are based on analytic methods. So, using empirical methods, it's possible to get any level of precision that's needed simply by using larger samples. This is important because empirical methods often are significantly easier to use. And, the act of creating a simulation often helps to understand the nature of the situation that's being simulated.